Okay, in this example, we're going to design a voltage divider so that, let's say we have a 12-volt battery, and we're going to do a voltage divider, typical voltage divider, 12-volt battery, and we want to get 9 volts out. So we also want to have low current. We don't want to use small resistors. We want to use bigger resistors. So what that means is we want to have a voltage divider where the output in between is equal to 9 volts. All right, so what I want to think about then is the ratio. So remember that my voltage at this point is the same as the voltage across R2. So we'll call this R2, we'll call this R1. And so we want to measure the voltage at this point at 9 to be 9 volts, and that's the same as the voltage across R2 because it's the last resistor. So what we want then is we want V2 is equal to the total voltage times R2 over, so we're doing the ratio of the last resistor R2 to the total resistance R1 plus R2. And we want that to equal 9 volts. Okay, so if we think about this, then we know that we can look for the ratio. So we can say R2 over R1 plus R2 is equal to, I can divide both sides by the V, which in our case is 12. So I know that's going to equal 9 volts over 12 volts, right? So that's our ratio. And so that's actually equal to 3/4. Okay, so if I have this ratio of 3 to 4, that means that my R2 is going to be um, in a ratio of 3 to 4. So I want to pick a pretty big resistor, right? So what if I said, well, an easy one is just to multiply by 1,000. So I multiply the top by 1,000, multiply the bottom by 1,000. So that means I'm going to say R2 is equal to 3,000. And I also know that R1, oh, this should be 2, R1 plus R2 should equal, so if that's the case, then R1 plus R2 has to equal 4,000. Right? If I multiply the top by 1,000, I have to multiply the bottom by 1,000. And so if R2 is equal to 3,000, then R1 must equal 1,000. Okay, so if I say, okay, this is equal to 1,000, and this is equal to 3,000, then that works, right? Because now I've got 3,000 over R1 plus R2 is 4,000. That gives me 9/12 or 3/4, and 3/4 times 12 volts gives me 9 volts. And so that's just an easy way to figure out my resistors for a voltage divider. And now to do a quick check for the current, because I want a small current, I is going to equal V over the Req, which in our case is 12 volts, over the equivalent resistance is adding them together, which is 4,000 ohms. And so my I is going to equal 3 milliamps, which is under 10 milliamps. So I feel like I've achieved my design task.